Welcome to More Learn, More Teach, where I attempt to simplify the complex. Hello, today we're going to talk about graphing inequalities. So let's start by graphing an easy function of y greater than or equal to x. So in order to graph this inequality, we got to start with what if it were equal, okay? So the equation of this line, this blue line, is y equal to x, y equal to x. If y were equal to x, this is what we would have for a graph. So now we got to look at, can y equal x? In this case, it can. So y is greater than or equal to x. Therefore, this is going to be a solid line because y could equal to x. Y may also be greater than x. So if this is the line of y equal to x, all of the values of y that are bigger than this line are also valid. Therefore, we would graph this inequality as everything greater than and equal to the line of y is equal to x. Don't forget your intercepts. Y is equal to x is equal to 0, y is also equal to 0, therefore it goes right to the origin. All right, another example. Once again, we have to graph what if y were equal to x plus 1. So y is equal to x plus 1 looks like this. I drew it dotted. Dotted because y cannot equal to x plus 1. So this is a limit. I cannot reach this limit. So I make it dotted to indicate that I can't actually be that value. What are our x and y intercepts? Well, if x were equal to 0, I plug in x equal to 0 into this equation and I end up with y is equal to 0 plus 1 or y is equal to 1. So y equal 1 is the intercept for this line. If y were equal to 0, then I'd have 0 is equal to x plus 1, which becomes x is equal to negative 1. Therefore, my x-intercept is negative 1. So now y must be less than x plus 1. This is the line of x plus 1. Therefore, all values must be less than this line. Look at y is less than or equal to 2x minus 1. We start by drawing the line of y is equal to 2x minus 1, 2 times the quantity of x minus 1. Look at our intercepts. If x were equal to 0, y would equal to 2 times the quantity of 0 minus 1. That becomes negative 1 multiplied by 2, which is negative 2. So the y-intercept is negative 2. If y were equal to 0, 0 equals to 2 times the quantity of x minus 1. I can manipulate that to 0 is equal to 2x minus 2. I can add 2 to both sides. I end up with 2 is equal to 2x. I can divide both sides by 2 and x equal to 1. So the x-intercept is 1. I can be equal, so y can equal 2 times the quantity of x minus 1. Therefore, this is a solid line because I could equal. I could also be less than the line. Therefore, I could be all values equal to or less than y equal to 2 times the quantity of x minus 1. So let's do this example. Y is greater than 2 times the quantity of x plus 2 minus 4. So if I were to graph this, let's look at y is equal to 2 times x plus 2 minus 4. If x equals 0, y equal 2 times the quantity of 0 plus 2 minus 4. That's equal to 0, right? So 2 times 2 is 4. 4 minus 4 is 0. So therefore, the y-intercept is 0. If y is equal to 0, 0 equal 2 times the quantity of x plus 2 minus 4. Distributing through, 2x plus 4 minus 4 equals 0. Therefore, 2x equal to 0. That can only be true if x is equal to 0. Therefore, x-intercept is equal to 0. So both the x and the y-intercept are 0. I cannot be equal to, so y cannot be equal to this quantity, so this is a dotted line. I could be all of the values greater than this line. Therefore, that is my answer. All right, so let's do a challenging example. Negative 2 times the absolute value of sine of x plus 4, or y is greater than 3 times the absolute value of x minus 3 plus 2. So we want to graph all of the possible values of y that meet these conditions. So let's start with this first equation here. So this first equation, let's start by graphing what does y equal to negative 2 times the absolute value of sine x plus 4. What does that look like? So let's start with sine of x. Okay, so this is sine of x. So this is y is equal to, right? So y is equal to sine of x. So now let's take the absolute value. Remember, the absolute value is going to be a magnitude only. So no change to the positive values, but the negative values are going to flip over the x-axis because I care about the magnitude, right? The magnitude is this quantity here, but up here. So now I can draw these humps as the positive. So now the green plus, here, I'll go ahead and this now orange line, this is y is equal to the absolute value of sine of x. So we've gotten this far. All right, so let's look at our multiplication constant here. So I'm going to multiply negative 2 times this absolute value of sine of x. So every point along here is going to be multiplied by negative 2. That's going to flip me over the axis, and it's going to skew my function. So what it's going to do, it's going to look like this. Flips me over the axis. My zeros are still going to be 0, right? But I'm going to multiply every point along this line can be multiplied by negative 2. All right, so this is y is equal to negative 2 times the absolute value of sine of x. That gives me this portion right here. So now I've got this constant. So every point along this red curve, I'm going to add 4 to it. So now it's going to be a little tricky, right? Because we want to know exactly where these points are numerically. All right, so if we know that the sine of x, the maximum value of sine of x is 1. So this was 1. When I multiplied by -2, that got me to -2. I'm going to add 4 to every value. So -2 plus 4 gets me to +2. So this shape is going to shift such that this minimum point is going to line up with the 2. So let me attempt to draw that. All right, so this graph right here is y is equal to -2 absolute value sine x plus 4. All right, so now we've done half of our problem. We now know what the graph of y equal to -2 times the absolute value of sine x plus 4 looks like. It's this purple line here. And we know that y can be a value that is less than this value. So the green hash is what meets this condition. However, I do have 2 conditions, so I've got to look at the other one too. So let's start with y is equal to x. So this is what y equals x looks like. Y equals x. Let's go ahead and use the multiplication by a constant rule. All right, let's skew this. So every value here is going to be multiplied by a +3. So that's going to tilt me towards my y-axis. So y is equal to 3x is going to look like this. Now that I'm here, I'm going to go ahead and time shift. So this is a delay. So I have a -3 delay to my x. So if x were to start here, it's now going to be delayed by 3. It's going to shift to 3 here. Let's go with brown. So this is y is equal to 3 times x minus 3. I have shifted by a value of 3. So this is x equals 3. Let's go ahead and take the absolute value. So everything that is negative just flips over the x-axis. Let's use blue. And we have y is equal to 3 times the absolute value of x minus 3. Now finally, let's do our shift on the y-axis. So this function now is going to shift by 2 up. To give us y is equal to 3 times the absolute value of x minus 3 plus 2. We've drawn our function of y is equal to the absolute value of x minus 3 multiplied by 3 plus 2. That is the dotted orange line because I can be greater than this, not equal to though, greater than, according to this. I have an or function, which means that I can either be in this red zone, right? So this is greater than, this function, or I can be in this green zone, which is less than this function. So I can either be green or red. That is my answer. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.